Hey guys, so today's lesson is going to be just slightly different than what we might be more used to, where today is being used mostly as an introduction to some additional identities that we may use in the future. So today I don't want them to jump out at you later on, so I want to just make sure that you guys have seen them because they can look a little complicated, especially how we start. So in this case then, if we are looking at sine of x plus y. Now normally what we have already seen is something like sine squared of x plus cosine squared of x, which we should immediately remember is equal to 1. But in this case, rather than adding together two separate functions, we are actually adding together two variables within a function. So we need to be able to recognize, one, what this ends up expanding to, as well as what it is that gives us this particular simplification. Now, this is helpful in a couple of different ways, but starting just to begin, recognizing that this happens for the three main functions, sine, cosine, and tangent, and for each of them, there's something just a little bit different, but still quite the same. So we're going to have an x, a plus or minus, in this case, y, an x with a plus or minus y, and then an x with a plus or minus y. Now I mentioned that they are similar but not exactly the same, and we'll see why in just a moment, because this sign of either one of these functions of arithmetic, either adding or subtracting, we start off with sine of x, and we multiply it by cosine of y. Then we plug in whether we are adding or subtracting, and we switch it up to cosine of x multiplied by sine of y. Now that is a very long string of functions that you may not regularly see right away. However, if you're ever going through simplification and you start seeing a pattern like this where you have a sine of a number times cosine of a number, then you might be able to simplify it together to give you sine of both those numbers added or subtracted together. Now before I get into any of the explanations and such of what I mean by any more into the explanations, let's get all of them on the board so that we could compare and contrast. So cosine, however, actually starts with cosine of x and cosine of y. We then put in whether we are adding or multiplying, and we switch to sine of x times sine of y. And tangent subverts the idea entirely and instead actually has a fraction where we take the tangent of x and we add or subtract it to the tangent of our y on top of 1 plus or minus the tangent of x times the tangent of y. Now in this case we have all of them out here. Let me just separate them a little bit so that we could actually take a look at them and kind of see something that we might notice so that we can kind of get them a little bit more, or at least memorize them a little better, so that when we see these in person within an equation covered by a variety of other functions and variables, we can actually solve for them. So in this case, starting off with sine, a good rule of thumb for sine is, well, if you're given a sign here, you typically will start with a sign. But more importantly, you'll see that it flip-flops. And what I mean by that is that the sine and the cosine will switch places between the addition or subtraction. where we have sine as first here, while cosine is second, while in this case, cosine is first and sine is second. Now that takes care of that for the sine and cosine, because we could see that sine to cosine to sine, they flip-flop over as they move through. But what about the x and the y? So the x's and the y's actually stay directly in place. You have a x first, and then a y second, and then you still have that x first and that y second. Now, of course, this is mostly because this is the standard. The absolute standard, you might see them. It is possible to see them separately, where you might see instead sine of y times cosine of x being added or subtracted within the equation. But as long as you make sure that it is on the second half of sine, that it's sine that has the y value, as it does here, and it is cosine that has the x value. Those are the important parts for sine of x plus or minus y. Now, when I mention that the x and the y's stay where they are throughout the entirety of all of these identities, the x and the y does not change. And so that's just a simple way of remembering that the pattern goes x, then y, x, then y, x, then y, x, then y. Tangent is a little bit different, but it still holds true that it's got an x and a y, and then it has another x and a y, even though they're being used differently. So sine, we saw that sine and cosine flip-flopped, as we see that it first has sine and cosine, then cosine and sine, while with the cosine function, we actually see that just like with sine starting with sine, cosine starts with cosine, but it fills up everything with cosine. The first multiplication is actually cosine and cosine, while the second is sine and sine. So this one doesn't flip-flop, it keeps consistent. Cosine is consistent, sine is sporadic. So this consistency allows you to remember that we've got cosine first with a mix of x and y, and then sine with a mix of x and y. Tangent is the weird one, which kind of comes into understanding just that it's somewhat of a memorization, that we have the tangents above being added or subtracted, and tangents below. The best rule of thumb here is that you're doing addition over multiplication, where it is understood that there's a 1 plus below, but ultimately for the tangent functions themselves, it is addition or subtraction, for that matter, over multiplication. In this case, these are the basic equations, identities that you might see for these. For now, I imagine the questions are basically just, rather than the questions given today are mostly, rather than simplifying and trying to find out like how to manipulate cosine or sine into a tangent, it is just rearrange the given functions so that you end up with sine of x plus y, or sine of x minus y, or cosine of x plus y, or if you're given numbers, to actually, rather than having to do the multiplication of cosine of x times cosine of y, or say cosine of 1/2 times cosine of 1, and then adding it to their sine counterparts, you can just see that there's a pattern and add or subtract the numbers within cosine itself, and then just do the equation once. So again, today is mostly just a showing of these functions. Hopefully, some of these tips for seeing them is helpful as we move on to some of the practice. But otherwise, I hope you're enjoying your day. Stay safe and healthy.